So today we're going to take the logarithms that we learned about and look at their graphs compared to the exponential graphs. So a logarithm function, y equals log x. Remember we said if there's no number there, it's base 10. So this is what the graph looks like. If you look at your table, 1/10 is -1. So -1, it's really, really close. It looks like it's touching the y-axis. It is not. If you put this in your calculator, it's really going to freak you out because it's going to look like it stops. Let's look. If I go log x and graph it, it just looks like it stops right there. Well, that's just because my calculator screen is pixelated and you can only get so close with the pixels. But just know that it doesn't stop. It keeps going down towards infinity, towards negative infinity. So my domain starts at 0 to infinity. My range is all real numbers. This time I have a vertical asymptote at x equals 0. So my domain and my asymptote are very closely related this time. Transformations, I still have my, I called it C and D here. The last time we called it H and K. Negative C goes to the right, positive C goes to the left, positive D goes up, negative D goes down, and A does all the things. So let's take a look at these. So I keep this in front of me so I don't get it confused with the exponential graph. So I'll talk about transformations and then we'll go back and compare our domain and range. Transformations are just going to look pretty normal. Vertical stretch by 4, right 1, down 3. Domain. Now, your domain had to do with your right and left. So I moved to the right 1 space, so my domain is from 1 to infinity. My range is going to be all real numbers for all the logarithms. So that's good to know. My vertical asymptote, remember that's related to the domain, so it's going to be x equals 1. Now, if I were to sketch a quick graph of this, I know this is a teeny tiny graph. X equals 1. And right here, remember I had this point 1, 0? That's the point that we're going to focus on. So if it was at 1, 0, I moved it to the right 1 and down 3. So go 1, 0, move to the right 1 and down 3. And then the basic shape of your graph is that it goes this way, and then it goes down towards negative infinity. So always start at that 1, 0 point, and then you can move that one over at a vertical stretch. If we were graphing it more specifically, we would take into account the stretch. All right, let's do the next one. Negative log x plus 5. So negative is a reflection over the x-axis. Ooh, that's going to be important. Up 5. So my domain, I did not move left and right. So my domain stays 0 to infinity. My range is going to be what it always is. My vertical asymptote is tied to my domain, x equals 0. So that's right here. Now, this one has reflected over the x-axis. So if I look at this and imagine it reflected, well, now it's going this way. Instead of pointing down, it's going up. So I did move up 5. So remember we started at 1, 0. When I reflect, this point doesn't move, but I go up 5. 1, 2, 3, 4, 5. This time, I'm going this way. That goes. And you know what? If that's confusing, I'm with you 100%. Let's type it in. Negative log x, you have to close that parentheses, plus 5. Can you see that? And graph it. Okay. This eventually does keep going down, down, down forever and ever. But my asymptote is, see how that looks like it stops? Keeps going towards infinity. All right, let's look at the next one. Log x plus 2 minus 4. Looks like I'm going to the left 2 and down 4. Okay, no reflections, so that's good. Notice the roxa didn't change my domain or range, because a roxa goes with your range, and for logarithm functions, your range is all real numbers. So a roxa doesn't mess with your range this time. Okay, so my domain, I went to the left 2. That changed my domain -2 to infinity. My range, all real numbers. Vertical asymptote was x equals -2. So that one's over here. So remember we had this point at 1, 0. I went left 2 and down 4. So I know this is going down towards negative infinity, and that one's going that way. Again, if you want to look at your calculator to see the graph, you're more than welcome to do that. All right, we've got the whole kitchen sink here. We've got every single transformation. So let's start with our reflection over the x-axis. Now 3/4, is that a compression or a stretch? Vertical compression by 3/4. X minus 4 goes to the right 4, and plus 5 goes up 5. My domain, because I went to the right 4, my domain is 4 to infinity. Range is all real numbers, like it always is. My vertical asymptote moved with my domain to the right 4 spaces, so x equals 4. 1, 2, 3, 4. There's my asymptote. Now, if you start with this point 1, 0, you move it to the right 4, and then you go up 5. 1, 2, 3, 4, 5. It's right here. A reflection over the x-axis means now it's going this way. See my two reflections? How they switched a little bit from that. And again, if that is weird, we're going to the calculator. -3/4 log x minus 4, close the parentheses, plus 5. Now see how it looks like it stopped? But we know it doesn't stop, it keeps going. So don't be thrown off by the calculator there. All right, you go ahead and do some practice on these, and we are done with our notes for now.